TECHNISOIL G5. I appreciate that many of you have had busy schedules this evening or prior arrangements, so I do thank you for being here. But I can assure you that the presentation that you are about to receive will not only benefit your organisations, but it will give you an insight into the future of natural service pavement. We will start the evening off by just giving you a brief introduction into how confidence engineering, DELTAgreen, and the product TECHNISOIL came to surface. You will then have a full presentation into the new product, followed by any questions that you may have. And we do ask this evening, please, if there are questions that you do need to know, then please speak up, and obviously we will be happy to assist. And then finally, we will have dinner. So I would now like to invite our first speaker of this evening, Mr. Ryan Elzin. He is the commercial specialist from the US Embassy in Doha. He would just say a few words on how CED and DELTAgreen found their new business relationship with TECHNISOIL G5. Ladies and gentlemen, Mr. Ryan Elzin.
Good evening, everybody. Thanks for the introduction. Just want to start by saying we're really happy and honored to be here with you. Just a bit of background. I'm with the commercial service at the US Embassy. We're part of the Department of Commerce, and we work with US private sector companies looking to do business in Qatar. So just a background to the relationship. One of the shows that we sponsor and promote every year is the World of Concrete, and we forwarded the invitation to the Al Jaber Group and its sister companies, where CED and Delta were nominated, and Mr. Abdullah Jaber was nominated to go attend the show, where they met TECHNISOIL there, and now here we are tonight. So I look forward, as I'm sure everybody here is, to learn more about the G5 polymer, and thanks again. Thank you.
Here this evening, we have from TECHNISOIL G5, Mr. Patrick Smith, who is the Global Technical Director, and Mr. Alan Stewart, the Vice President of Global Sales. So they are here in Doha with us, and I'm sure that you would all warmly welcome them. So ladies and gentlemen, if you could please welcome Mr. Patrick Smith from the US, who will now give you the full presentation that you've all been waiting for.
Good evening. I'm glad I could be here, and I'm glad you guys all could make it tonight. And appreciate your patience while we got going. I'm here tonight to introduce to you guys our product. It was developed in 2006 by our president, Sean Weaver. G5 is a polymer. It's green. And we feel that it will revolutionize road construction over the next 40 years. Originally, G5 was developed for roads, winding roads, haul roads, in mining industry. It turned out that there was many other applications that G5 could be used for. Over the next 40 years, there will be millions of kilometers built over the world, and with everything we have going now, there's going to have to be a sustainable product that comes about. G5 is a polymer. It's a liquid. It can be petroleum-based, bio-based, cracked from natural gas, or made from CO2 emissions. G5 can also be made from recycling plastic bottles. We are globally set up with Dow Chemicals out of the US. They have regional plants all over the world, in Dubai and in Egypt, closer. They have given us global logistics at our hand, anywhere we want. And G5 also can be stored long-term without heat. Once it's made, it can be transported, stored, and used within a year with no issues. The process of constructing roads from G5 can save up to 50% from carbon emissions. This comes from the heat being replaced from asphalt. Cold applied systems also save construction equipment. The constant exchange of heat and cold in the equipment, the abrasiveness of the aggregates wear on the equipment. With G5, the wearing goes down. With the reduction of emissions, G5 reduces the footprint. It reduces the area that you have to account for because of the emissions that you emit with standard construction. Transportation costs are reduced, especially if you're in an area where you're pulling aggregates or minerals from out of the region into your area. The strength of G5 overcomes the weakness of the aggregate. It's the G5 that's providing the strength in the material. G5 can use recycled materials, recycled concrete, recycled asphalt, without the addition of aggregates. Just the G5, and you can create a road. It's faster construction. Everything is on your site. You don't have trucks or transportation coming through traffic jams or different situations. G5 is a natural polymer. It doesn't have any color. So the material that it's mixed with, that's the color that you're going to get. If you have a tan aggregate and you mix the G5 with it, you'll have a tan road. This reduces the heat absorption into the road dramatically. Longer life cycles. The cycle of heating and cooling of asphalt destroys it. Not just the trucks and all the weight that's put over it in axles. So G5 is used around the world right now on roadways, runways, service roads, military installations, landscaping, pond linings, walkways, and cart paths. We have 3 major clients in Silicon Valley right now. 2 of them are showed here. We're working on cart paths, parking areas, walking areas, wineries, and museums and institutions. We're also working with the U.S. federal government for implementation of our recycling process into forest highways. Around the world, we have roads, industrial applications, desert roads, wineries, universities, and freeways. There's a lot of stabilizers, they call them, out there that you might try to lump G5 into. It's not a stabilizer. G5 is not water soluble, and it's not made with water. The stiffness of G5 when mixed with mixes is near the stiffness of asphalt. But G5 can produce a high stability. Expansion and contraction is virtually zero between -50 and 50 degrees Celsius. Tensile strengths are typically up to 8 MPa. Compressive strengths typically up to 33 MPa, all while maintaining flexibility. G5 is semi-rigid. It can take the load of a car, but spread it out. Where asphalt, when you have an axle go over a roadway, there's a point load. point load after point load after point load leads to failure. The point loading is spread out with G5, but it can still retain its flexibility. This is a mechanistic analysis of G5 over base rock, 5 centimeters on 10 centimeters. Compared to asphalt, G5 is 4.3 million cycles to failure. Asphalt is 0.4 million cycles to failure. When we look at 10 centimeters on 20 centimeters, G5's 93 million cycles to failure. Asphalt's 14.2. These cycles represent one axle from a 18-ton truck. G5 is highly resistant to rutting. In the United States, there's a test, AASHTO TP79, and it's the flow number. It's basically when your layer starts to have tertiary flow, when it starts to rut and when it starts to fail. For a road that's designed for 30 million ESALs, or 30 million axle loads, the minimum requirement is 740 cycles. It's a loading and unloading test. G5 has no tertiary flow after 20,000 cycles. G5 can also be used as dust control for stabilization on dirt roads, and we can also do permeable pavements. This here is a sample of G5 with a 6 millimeter aggregate, single-sized. You can pour water straight through it, and it's in the range of 8 MPa. In the United States, a lot of this is put around tree wells where they don't want to put the metal grates. In the United States, they're limiting the amount of water that you can discharge into the sanitary sewer drains. They can make walkways out of this, and the water doesn't get gathered. The water goes straight back in. They take care of it on site. This here's a sample of dune sand with G5. With the right types of sand, you can get up to 19 MPa with the dune sand. This is great for rapid road construction, or a natural looking path, or a natural looking median. It blends in with the surrounding area. As I've been here for 4 days, driving around town and looking at everything and seeing this great city, I see these piles of aggregate everywhere. And it's limestone, I guess. It's just under the quality to use it with asphalt, so you have to import material. G5 can take the limestone and you can produce a road that you can drive on, eliminating bringing materials in, eliminating the stockpiles. This is a mineral pigment. Can be added with G5 and sand in any color. Walkways, paths, stone. So we're here tonight to introduce G5. There's going to be a lot of questions, and we'll be ready to answer them. This is our first time introducing G5 in Qatar. And we hope that the future brings much promise in advancing the roads here and creating a sustainable environment. Thank you.
What kind of testing is?
Gradation.
And second question. Yes, first question, what kind of tests can be conducted to ensure the quality of this one? And are there any special batching planned for production?
Testing is going to be just like asphalt, an asphalt product. Gradation, oil content, compaction, and smoothness, obviously.
So it as a flexible pavement to be tested as a flexible pavement, not rigid pavement.
Absolutely. The process is exactly like you would pave with asphalt. It goes in through a paver, comes out of the paver, it gets rolled.
And regarding the rate of production from the batching plant and for the pavement also.
The batch plants are basically a twin screw pug mill, like you have in any typical asphalt batch plant. So if you have the plant on site, or if you have a mixing machine on site, you don't haul it anywhere. You can have the material on site, mix it on site, and place it right away.
Okay. So regarding the pavement production also?
I'm sorry?
Rate of pavement.
Rate of pavement?
Yes.
As fast as your mixer can go.
To pave. Yes.
Yes. Rate of pavement. If paving around here is 250 tons per hour, then you can pave 250 tons per hour with the right mixer, with the right batch plant.
Oh. Okay. Thank you.
The most challenge factor that we have here in Qatar, in the Gulf area, is the temperature. Can you tell us more about the stability of the product under 60 degree or 55 degree? Thank you.
Stiffness of G5 doesn't drop when the temperature goes up. The stiffness creeps up also. Doesn't get stiff, but it does not fail like asphalt does.
To which the limit, the maximum limit that can reach or support?
80 Celsius is as far as we've ever looked into it.
80?
80 Celsius. I don't think there's 80 Celsius here. Maybe there is.
No, it's possible.
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 Surface temperatures, yeah.
So what about the water? I mean, it's true that it's a hot climate here, but certain few times or few days we have a heavy rain, like 3 hours raining or 6 hour raining.
Tensile strength ratios are very high. It's highly resistant to moisture-induced damage. When the G5 encapsulates rock like asphalt would, it's like a cured plastic, right? It's strong. The water doesn't penetrate it like it would asphalt. So it's highly resistant to moisture-induced damage.
My question is the maintenance. If is it required heavy maintenance, or it's a normal maintenance, or if there is any personal expertise to repair or to do any
If
kind
you see
of patching.
the asphalt roads and they pave them and 5 years later they come back and they crack seal, you would do the same thing in the event that you needed to crack seal it. You would use the same binder for maintenance, right? The G5.
Or just fill the...
It's patchable. It's grindable. It's patchable. It's sealable.
I have some questions anyway, related also to asphalt pavements. First of all, what's the average? What's the range of the material to be used in a specific sieve, specific graphic of aggregates? I mean, let's say that we have the same material to compare it with an asphalt mixture, such as a wearing course, for example, and you have a specific sieve analysis for these aggregates, comparing the bitumen that you have to use in a mixed design. What is the percentage that you could use of this material in order to achieve similar characteristics of the pavement?
Yes, if I understood you right.
Yeah.
The materials locally here are obviously going to be different than the materials that we use in the U.S.
Scabros. Gabbros.
which is it's like a granite.
Yeah.
The gradations follow asphalt gradations. Typically, below 10% on the 200 screen.
Below?
Below 10% on the 200 screen. Above 2% on the 200 screen. The air void target is in the same range of asphalt. We're looking for placement, absolute placement below 9% air voids. Nothing above 10% air voids because you have interconnected voids and you'll create another issue.
The cost comparing to bitumen pavements.
Cost comparing the bitumen paving here in Qatar is cheaper. Cheaper than bitumen paving.
And what about the binding bridge that you have to use? You have to use a prime coat in order to apply it upon the foundation of a road?
No prime coat on aggregate base. We don't recommend a tack coat on asphalt, on overlay.
No recommended.
No tack coat on the overlay. It's the free binder that's on the underside of the rocks. Adheres to the lower layer. It's basically like having a tack coat. Would provide, if you were to tack with asphalt there, and then pave G5 over tacked asphalt, you would get better tack if you just left it clean and put the G5 on top of it.
Do you have some mixed designs, optimal mixed designs for this specific material?
Yes. From the US, Kazakhstan, not from Qatar yet, but now that I'm here, I'm working on it. Absolutely.
For sure, anyway, in the case of somebody wants to apply, he will have a technical solution from you anyway related to the material to be used here, isn't it?
I'm sorry, I didn't catch that.
In the case that somebody wants to use your product, you could provide technical support.
We have
mixed designs and all these necessities that could be in order to apply this material to his project.
Absolutely. Or work with your local labs here. We have installation specifications, mixed design specifications from the US. Mostly based on ASTM, which from what I hear transfers over pretty easy, but there's other test methods as well.
What's the maximum thickness can be laid on one time? And can we use on existing asphalt or existing concrete?
Yes. The maximum thickness for paving applications that we have is 4 inches or 100 millimeters. If you're doing stabilization with the stabilizers sometimes can go down to 400 millimeters or 300 millimeters. In that case, that's what you get. You get what you get. But 100 millimeters, one layer for asphalt is the maximum that we recommend.
100.
The reason being, most places only recommend or allow 75 millimeters or 3 inches in one layer. G5 has a lot more lubrication properties than asphalt. The compaction comes faster.
Thank you.
I want to ask about, for example, for the wearing course, asphalt concrete, the percentage for the bitumen is 3.8%. 3.8, 3.6, 3. Like this, yeah, maximum 4. What is the percentage I will add from this G5 for the bitumen content? Because it is bitumen, it is additional material, correct?
Just a little bit closer.
Close. Yes, just a little bit closer. Okay. Sorry. Yeah. This is, I am asking about the asphalt concrete wearing course.
Wearing course?
Yes, the percentage of bitumen content, it is start from 3.6, 3.7, 3.8, 3.9. Now for this material, G5, what is the optimum we will add to have the all
OBC.
properties of this is to have properties higher than the asphalt concrete or similar?
OBCs typically range on our recycled asphalt product,
Yes.
which is 100% recycled asphalt mixed with G5. OBCs typically range from 3% to 5%. This is a ground asphalt that may have 3.5% to 6% asphalt in it to begin with. On a wearing course or an open graded mixture with
Yes.
virgin aggregates, you may be looking at
Other question. This material, I see the sample outside, it looks like it is a rigid material, it is not a flexible. Is it a flexible or it is a rigid? Because it will be cracks. If it is rigid, it will be cracks. Earthwork.
like
And-
road stabilization.
Yes, all film, yes.
Yes, stabilization, absolutely.
And what test you are performing for this one? Test compaction, and
Compaction.
CBR, and this you are.
Well, it's gonna depend on what job you have and what the application is. But it can increase the CBR. If you're looking to increase the CBR, you may only add 1% or 1.5%, depending on what you're looking for. And then you would test compaction when you're out there placing the material.
Also, if you will use in Qatar, do you plan to conduct a pilot project, for example? If you will start, that means it will take minimum 1 year to see the performance of this material. You cannot direct, okay, you will use it. You need a performance of this material at least 1 year. It is not direct and results.
Yes, you want to see it placed and watch it through a year.
Yes, after 1 year to watch this, it is.
We start right now.
From now, for example, if you start from now, at least 1 year.
We have other places that it's installed. Previous projects, not in Qatar, but
Yeah.
yes. It's a good place to start, is getting the materials, figuring out what you guys want to see as far as G5 and being certified for freeways or highways or what have you. And then getting that going and having you look and see what else has been done.
Okay, thank you.
Good evening.
Hi, how you doing?
It's Mohammed from Al Jabr Trading and Contracting. Well, to me, G5s looks useful, but I got a couple of questions in here. Well, first, why it's been called G5, and how long it will last for our next maintenance period, and how long do you expect that the durability of this will last?
We're looking at targeting 40 years, a 40-year life cycle, 40-year design life cycle. That in the U.S. that follows concrete. In the U.S., asphalt, unless it's long life asphalt, is designed for 20 years. Long life, maybe 30, maybe 40. We're targeting that same deal, same year span here. Degradation. We know that the material's solid plastic, inert solid plastic when it's cured, and we don't expect it to really start to degrade for 75 years. That being said, you have the sun every day, it's obviously going to beat down on it. So a maintenance overlay or a maintenance seal after 5 to 10 years is going to be something that probably needs to happen. At that point, you can overlay it or seal it, pigment it, seal it if you want to change the color of it or do something different. There's many options because it's natural, just like the color of the material you're using.
That takes me to another part. What if we have used the G5 in a product and the next life cycle we would like to use the same product on the same layer? Are we going to be able to remove it, or we can place only on the top of the layer itself?
You can grind it. It grinds.
Using the same machines of milling that we have usually for asphalts?
Absolutely, absolutely. Carbide teeth or diamond teeth, either of the teeth will grind it.
Good evening. I'm Francisco Santiago from KBR Asgal. I would like to ask about this permeable property of your pavement.
Yes, sir.
A while ago, you told it's moisture resistant. How could that be? And another question is, does it require any stabilization of the road base? Because sometimes the groundwater will rise and possibly water will come out of the pavement. So does it require any special stabilization or any geotextile treatment of your road base before applying this permeable pavement?
I think I follow what you're asking. Permeable pavement is not necessarily something you want to do. Aesthetically, in areas where you can control the water and get it out of the, off of the road, but to have a whole road that was permeable, you're asking for the water to go through and fail the road. The moisture resistivity, it's not necessarily permittivity. The water's going to go through it.
Okay.
It's highly resistant to moisture-induced damage, which is the water transferring the layer in between the binder and the aggregate, back and forth.
Because I could see there could be exfiltration coming out of the groundwater table because it's permeable.
Yes. If you had the situation where water was forced up,
Yeah.
it would come out.
So
Where
how do
if
you-
it was a covered road, a dense graded road, maybe it would work its way out to
So
the
how
side.
do you control the situation in case there would be some rising of groundwater table?
You would want to put a dense graded layer down below and maybe just put a cap of this material on top, directing the water away from the road and not down through the layers.
So it will require some ground stabilization, just like application of geotextile
Yeah, it's,
in order to correct.
or a layer that's solid through, a layer that's dense graded, that's tightly packed and has no permeability. And then you could put the layer on top. Like in the US, we call it open grade. They build the road and they put the layer of open grade on top, and it lets the water shed out to the side, and it reduces hydroplaning that can happen during big rainstorms.
Thank you for the presentation of this good material G5 according to what you have just mentioned. I'm Wael Taqi, I'm working for the Public Works Authority. I would like to know, have you got any qualifications or certificates from any third-party institution who would certify this material that internationally accepted? That's one question. The other question, for a pavement, we normally specify the PSV value, which normally comes from the polish service value for anti-skid material. How do you evaluate this G5 in terms of anti-skid?
Anti-strip?
Anti-skid, for safety, you know. For
Anti-skip.
Skid.
Anti-skid.
Yes.
In country, we're going to follow whatever regulations you have, but typically in the US, it's the British pendulum tester, or in California, where we're from, Caltrans, California Department of Transportation, has their own skid testing. What we've seen that it's at least asphalt, if not greater. And any skid, there was another question also you had. Specifications, we're working with Federal Department, US DOT in the United States right now. We are specified in the Russian Federation, approved for construction of roads, runways, freeways across the whole nation there. We're working with the California Department of Transportation right now, UC Berkeley, for a long-term pavement study to implement it into Caltrans as well.
Is it recommended, the last question, for local roads or for expressway, for heavily trafficked roads? What's your recommendation for this G5?
All of the above. Heavily trafficked roads, local roads, it's going to be based on the design. What you're looking for, design it based on that.
You said it's cheaper than asphalt. What are we talking about? What's the percentage? How much is cheaper by? 20%, 30%?
I'm the technical guy. It's recycling is greatly reduced.
No.
Because you're not bringing in new aggregates, you're not firing the asphalt plant, you're not driving the trucks from the paver to the asphalt plant.
How much are we talking about in terms of percentage, please?
What's the percentage? Cheaper. 40%.
40? 40?
40.
You sure? Sounds a lot.
Sounds good, right?
Sounds too good to be true, actually.
Well, there's a few different things that are going to happen that you'll figure out as you go, right? 2 inches of asphalt on 4 inches of base, or 5 centimeters on 10 centimeters of asphalt is going to give you this much axle loads. So
from your own experience, I'm saying to date, I'm sure you have done that comparison. What was it? It seemed that you're not sure yet.
I'm sorry.
From your experience to date, you've surely done some comparison. What was it so far?
1,000 kilometers from an asphalt plant, we might be 60% cheaper because they don't have to haul any rock in. If we're right next to an asphalt plant in downtown Los Angeles, we might be 10% or equal of asphalt. It's going to range greatly over the areas. It's working like a bitumen.
Comparing the two pavements, one is made by bitumen binding material, the other is made by G5. So comparing as quantity and as a price, bitumen to be used and G5 to be used, what's the result that we are giving in order to find out where the difference is in price per square meter of pavement?
Without transportation.
Without transportation, without workmanship. Okay, because what you are discussing about recycling asphalt, you have to compare G5 recycling pavement with bitumen pavement recycled asphalt. Otherwise, you don't have a way to compare them together.
From what we've seen in town, you guys have the different types of paving. G5.
I mean, we're discussing about a specific mix design with bitumen. The same characteristics that we have received G5 with the same aggregates. We would like to have, let's say, an estimation cost in order to be able to understand if this solution would be. Actually, based on this question that the gentleman asked before, that's a very important question in my opinion. We have to compare similar things. I mean, one pavement with bitumen, the other pavement with G5. So we're discussing about the same aggregates, the same granulometry, sieve analysis, whatever, however you call it. And the material, instead of the binding bridge of the aggregates, instead of bitumen should be G5, if I understand well, isn't it?
So raw mixed price, without shipping, without design, or without anything.
Let's say one example to be more clear. Yes, let's say that we have an asphalt pavement of 4% bitumen.
4% bitumen.
Yes.
4% G5.
Yes, not 4% G5.
Same mixed design.
The same asphalt pavement that will be produced with G5.
Absolutely.
What percentage of G5 would be needed for the same aggregates? And what's the price per ton, I don't know, per cubic meter of G5 comparing to bitumen?
It's going to be within 0.5% usually on
so half the
OBC.
Half the quantity of needed bitumen, it's required for G5 pavement.
No, it's usually going to be within 0.5%. Because when asphalt's hot, it's near the same viscosity as the G5 and it does the same coating. You get near the same film thickness on it. but there's variations. The price, side by side, is going to be cheaper for G5.
You know, the bill of quantities of the contractors, they have to compare anyway the two cases in order to be sure that they will apply something cheaper and more effective at the same moment.
Sure, for it to make sense, absolutely.
Yeah. Otherwise, it's vain labor. I mean, if you are not able to answer to this question, yeah. What's the price per square meter of pavement? We would like to know.
Direct cost.
Direct cost. Not transportation, not workmanship, just the material. Yeah.
Here in Qatar?
Yes.
I don't personally have that exact number. I know that it's cheaper from what I've been told. For your guys' prices here, what you pay to put down asphalt. I could tell you it varies depending on where you're at, but asphalt varies also. So if we're cheaper there with everything that goes into it, we should be cheaper here. And from what I've been told, we are cheaper here.
Okay.
It can come in tankers, rail cars, on ships. The price per ton varies based on how much you want to buy. I am the technical guy. I can't give you a hint on how much the G5 costs per ton. I'm sorry.
Bitumen and G5, the comparison.
The cost between bitumen and G5? That's what he just asked me, right?
Yeah. I'm keeping it because I would like to ask a technical question later.
Yeah, if you're comparing a mixed design and it's cheaper, it's going to be cheaper. But previous experience per cubic? Between 20 and $26 is my experience in the U.S. for recycling.
May I ask a technical question? Me. So one gentleman before us told that about the characteristic of the pavement, and you told that it's semi-rigid. And at the same moment you told that can be used like stabilized ballast as a sub-base of the asphalt pavement. That means that it's not recommended for flexible pavements, or if it would be applied, it would appear in a flexible pavement. It would appear some reflective cracks, or it would appear sometime later anyway potholes. I understood well something like that, or not?
If you're just using it as a stabilized agent in the soil to bring up the CBR,
yes,
there's not much change you're going to make to the properties of the soil.
No, the properties of the soil will not be changed. But if, let's say, you use it like a stabilized ballast, sub-base, that it's a rigid material, floating upon a flexible foundation, all the vibrations will be reflecting to the top, will start having cracks, that these cracks will appear upon the asphalt pavement, where we call these cracks like reflective cracks. This is for flexible.
I've never witnessed that
environment. Yeah.
I've never witnessed it, and maybe there's a test that covers it, or are you asking it about a test result?
But like a test, actually, if it has been applied to an environment like that, and what results you get, or in a case that hasn't been applied, what's the Beckelman reading, the deflectometry readings, optimal for this case of for this type of pavement?
I understand.
Okay.
I recommend that we talk after this, and I can get you DCPs.
If it's not interesting for
yes.
the rest, anyway. But reflective cracks, I believe it's one of the characteristics of the final asphalt arrangement that everyone is interested.
Absolutely.
So if you give an answer, in which case it would be better to apply this kind of experiment? I mean, for example, here is a rock foundation. It's limestone. Is it recommended for this type of soil, or is it recommended for clays, let's say?
What we need to do is we need to take the soil, right? If you're looking to build a freeway and get a study on it, the material needs to be tested and designed for for however thick it needs to be on that type of a subgrade. Sometimes they do concrete in other countries, 400 millimeters just to
Maybe I misunderstood. What is it called? It's semi-rigid.
It's flexible.
It's different than flexible. Flexible and semi-rigid or rigid are different things. If we're discussing about flexible pavements, we are looking for flexible materials. If we are discussing about rigid pavements, we are looking for rigid or semi-rigid materials. So what's the case of these materials?
I can tell you that the binder has an elongation, and the elongation is between 100 and 300%. The elongation of the binder.
Sorry, sir. Can we just spread the questions around, because there's other people also that need to answer. Sorry, sir. We'll come back to you in a minute. Do you want to just...
Yes. Is G5 suitable to be used in road safety program for anti-skid resistance at the approaches to the traffic lights or pedestrian crossing at grade? But in other words, can you mix it with anti-skid resistance with a thin layer, okay, which improves safety at the approaches? Particularly here, you can see in Qatar, drivers, they don't comply with the speed limit and they go very fast. And when the lights turns from green to red at a very short period of time, sometimes they don't stop. And sometimes a lot of accidents could occur.
All of the testing on skid resistance we've had done, it improves the layer. If you wanted to do a spray coating, maybe with some sand in it, it would highly increase the skid resistance.
I mean, is it possible to apply for a sample? You choose one of the sites and apply it and get the local authority or Ashgal to test it in order to say, yes, this is valid, we can use it for future.
We would welcome that. Okay, great.
Thank you.
Thank you.
I have one more question here, Mr. Sir. Have you tried using sludge from wastewater treatment plant?
Steel slag?
Applying G5 and convert it into a pavement or sidewalk material, something like this?
Did you say steel slag?
Sludge from wastewater treatment plants. The solids from the wastewater treatment plant, it's being used.
I personally haven't done any testing with it. I can check.
Yeah, please.
I can check. I personally don't know of any testing that's been done with it.
Thank you.
As well, I know some of you had quite a lot of questions this evening, but obviously once you all go back and you discuss obviously what you've seen today, please give one of us a call. We can arrange a meeting with you all and we can discuss personally, individually, so that all your questions can be answered. So I'd like to thank you all this evening for coming and seeing the presentation, and we're very grateful. And I think you'll all agree that after seeing the presentation that the product will do very well here in Qatar. So we'd like to welcome obviously the product here as it's beginning. Now, ladies and gentlemen, again, thank you. Enjoy your evening. Now, if you'd all like to go through the doors and enjoy your dinner. Thank you very much.
you.